The largest ever cybersecurity incident that could have been in the Linux world was prevented by an engineer that works for Microsoft. Well, you don't hear that every day, so let's find out all about that. My name is Lieuwe Jan Koning. Welcome to Threat Talks. And here from the headquarters at Onto-It, we bring you the deep dive of the XZ Utils vulnerability. Let's get on to it. Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity. Let me start by introducing my two guests of today. On my left-hand side, it's Thomas Manolis. He is the Information Security Officer of AMS-IX. And AMS-IX is one of the largest internet exchanges in the world. Thomas, welcome. Could you explain a little bit what you're doing and what AMS-IX does?
Hello, everybody. Thank you for having me at the Threat Talks. Well, I'm the Information Security Officer, as you have prolonged me. I'm ultimately responsible for the Information Security Management System of the Amsterdam Internet Exchange. The Amsterdam Internet Exchange is one of the biggest internet exchanges in the world, and we have a peak traffic of 13 terabytes per second, so you can relate, that's a lot. And behind this fantastic number is hidden a fantastic organization where I represent in terms of security. So this is what I do in life.
Thank you very much for doing security at AMS-IX. It's really important. That's great. Hey, Jeroen Scheerder is my other guest of today. He is a security specialist at Onto-It. He knows everything about kernels, about encryption, about a very long list of things. And I have a feeling we need him today because it's quite interesting technical subject we're having today. Gentlemen, it is the XZ Utils backdoor. Thomas, maybe let me start with you. What happened here? What's the...
Well, let's start with the basics. The XZ Utils is a very common utility within the Unix world. So many Linux distributions rely on it in order to perform a high ratio compression. And what has happened is that during 2024, at the beginning, between February and March, possibly the biggest the most successful supply chain attack we have ever seen has been performed because we will analyze in a few moments what has happened in detail, but it took time, effort, knowledge, and other aspects that it's hard to find to ordinary people. Most probably we are talking that some state threat actor was behind this attack, and we will analyze in a few moments.
It took a long time. You mentioned 2021?
Yes, it all started
when they started
at least, based on what we know, as we said with Jeroen, as of 2021. So the guy, Jia Tan, built credibility little by little by contributing to GitHub small fixes to random projects here and there. And then he focused on the XZ Utils, where the maintainer of the repo was under personal, he was facing personal issues back in time. There have been mental health issues, work-related, that in modern working environments are very common nowadays. And he started to convince the real maintainer of the repo to provide him commit permissions in GitHub in order to perform his attack and inject a backdoor to literally almost every second Linux system on the world.
Yeah. So XZ Utils, it's in the Linux world, Jeroen, that's not just a nerd that has a laptop with Linux. Linux is everywhere these days.
Oh, wish it were so simple. No, it's a complex ecosystem in which many individuals carry a shared burden. And of course, which gives rise to a lot of issues. So many projects interact or depend on one another, and it's high pressure. So we depend on a lot of moving parts, which are effectively managed and executed by small groups of individuals.
Yeah, so the small group of individuals maintains this package. This package is included in Linux distributions. Probably a lot of cloud instances that have it. Maybe phones have it. Maybe I don't know what not. Everybody who needs some form of.
In this case, so it's Linux specific. It depends on a few internal details. So probably not your phone. But either way, yes, it potentially affected Linux installations. But of course, it's not just this single individual, this small group that actually pushes that stuff onto your computer. There are other organizations and groups of individuals that manage distribution and do quality controls and that offer introspection.
Is it a bit similar that we have seen Log4j, right? That was also a library somewhere on GitHub that was widely used by many
pretty much
developers used it, and this is similar. But in this case, it's not for logging, but it's for compression, a specific form of compression.
The goal of the library doesn't matter. You can do something to a library that makes it expose undesired functionality.
Yeah, so what was the exposed functionality this time in this case? You mentioned SSH.
Right.
And SSH, for everybody who doesn't know, that's a mechanism to remotely log on to other Linux-based systems,
right,
with a certificate. I mean, you need to have a certificate typically, and then if you present a certificate, then you're in, and then you're on the system.
Well, the vulnerability affected some unstable Linux distributions. So it affected the Debian, Fedora, OpenSUSE based on what I remember, and some Kali Linux distributions for about a week, based on what we know so far. So basically, what was happening is that an affected system would have pre-integrated a backdoor, and an attacker with a predefined SSH private key could, could have access to the system and also remote command execution capabilities.
Okay, so there was a key pair somewhere, and the public part of that key was through this library injected into SSHD for some reason, in some way.
Yes, let's say.
How?
Well, it's a very well obfuscated attack on the source code, and it was performed that way, where it was very difficult to be identified by the classic and automated software development processes, test processes that we usually perform. So what has practically happened is that there have been a number of conditions that must be satisfied in order to trigger the backdoor. So this was not always possible. These are the good news. And what was happening is that there have been two test files along with the distribution of the tool itself. That within those two test files, it was hidden the script that would have, deployed the backdoor on the affected system.
Yeah. So that was how they didn't put it like on Spotlight. Listen, it's not like here's my public key and put it in anywhere.
No.
But it was in that way obfuscated. But
it's a modification of the handshake. So you walk to your door, insert your key, and there's an invisible one inserting its own key.
Aha, that's what happened. And that's the piece of code that they put in the library. And if you installed SSHD, which everybody does, and then also XZ Utils, the combination of them, that would change the key.
It's a little bit more complicated. There are other,
more moving parts.
Yes, there are more moving parts. So there are more dependencies.
By the way, if you would like to follow more and see look at diagrams and everything, we have infographics ready for you. So if you go into the show, you could pause for a moment this video and look in the show notes and get them so you can watch along with what we're saying. So yeah, you were saying.
Yes, well, I was saying that the obfuscation was definitely of high quality. It's knowledge about software development processes that you don't find that easy nowadays, and it makes us believe that behind this attack, most probably it's a state actor or a similar
so sophisticated,
threat.
No single guy could do that probably.
Yes. And I'm afraid that we don't know who Jia Tan really is, and I don't know if we will ever find him or her. because I think that this attack was kept, by a small circle of state threat actors, or even from a single person.
No, there's a lot of conjecture there, of course. Interesting is that Jia Tan is an anagram for I agent.
Nice.
So, and there has been the suspicion on that as well.
Yeah.
And his long name, of course, is an anagram for CIA agent. But, well, we just don't know. And if you go into that gray area, anything can happen. It can also,
absolutely.
It could be a group.
This is a good source of all kinds of conspiracy theories.
Oh, of course,
Yeah,
of course.
absolutely.
But we need to stick to the facts. We have this subversion of a public library used in different software projects, and in the context of SSH, it's inserted a rogue authentication facility into the handshake. So that's bad enough.
Yeah, because it didn't change the files on the files. It wasn't like it didn't add into the files of allowed public keys.
It
was
injected
in
stuff
memory.
in the handshake.
Yeah, that happened all in memory. So you couldn't look through your file system and find it.
I think that this is not the case, based on what we know so far. Mm-hmm. I think that it was not that easy to identify it. It was possible, based on some researchers, to identify it on some system variables. You were, looking for a specific string, and if you would have found it, possibly...
Yeah, after you understood the attack, but it wasn't obvious in your face that that this thing happened, and you couldn't...
But it was not hidden like the Thompson login attack, which was not visible at all. Mm-hmm. And not visible in the source code even. This was sort of less sophisticated than that. But so if, after the fact, we can check for the presence of files which have been modified in this way. So
it's not traceable, but not in the open, not obviously.
But this is only after we did the root cause.
I mean, we're going to talk about how it was prevented or quickly retracted, this update, in a minute. But if it wasn't caught, there was the guy then somewhere with a private key that could log on to any system that had the XZ Utils library installed that was affected. Was that so? There was like a God mode kind of key available for Linux then.
Kind of, because there have been a number of other requirements that have had to be met in order to exploit this vulnerability. So not every Linux system with XZ Utils was affected. Let's be clear on that, and thank God this was the case, of course. But again, it was the start of a very, very big attack, and we are very glad that Andres Freund identified the threat at the very early stages, and we got rid of it.
Yeah, however, Freund means friend in German, so he's really a friend of the cyber.
He is friend of of everybody on this earth, I believe, because everybody is using directly or indirectly open source software. So it was a very important.
How did we get to it? Because apparently it got committed to the repository. It was then incorporated into the updates of all the operating systems. They and therefore distributed in Fedora and all the ones that you mentioned. How did Andreas figure this out?
Well, so let's start with a detail. What was committed to GitHub, it was not actually the actual code that was present at the software repo. So that means that there has been an inconsistency between the two. So a checksum check would have.
Oh, you mean that in the actual repositories of the operating systems was different code?
Yes.
Then in the official GitHub repo of XZ Utils.
Yes, exactly.
Well, usually these things get distributed in two ways. You can check out the source code and build the software yourself, or for convenience, you can use pre-compiled binaries. And in this case,
I'd rather do apt install package instead of.
You're not a Gentoo guy then, right? So yes, so it wasn't visible. It wasn't present in the source, in the repository. It was present in distributed binaries, which should, of course, never happen. Projects have mechanisms to do signed binaries with checksums, and these checksums are protected using PGP keys and so on. So the attacker had to bypass that. If we dissect this, we see exploits and vulnerabilities at many levels. We have discussed the technical things. We saw the fragility in systems in which dependencies introduce vulnerabilities. But it's also, of course, a fragility at the social level. Few individuals bear high responsibility, so they are at risk of mental burnout. So there is a mental health vulnerability here. And there's also a social engineering question in which this Jia Tan, supposed individual, actually put pressure onto the stressed out and burnt out maintainer to hand off responsibility of project maintenance, which of course can be done in good faith. You help one another. But in this case, of course, this was pressure exerted to gain the level of control needed to do malicious things by means of this software project.
So for one more time, it was proven that the human beings are the weakest link in the security chain. Even if there are many people who dispute this, it was the truth for one more time.
Yeah, okay, but there can be many controls to try to prevent this. And what you mentioned, like there is a binary that is different from, you would go to GitHub and look at the source code. It looked okay, but the binary is then not based on the actual source code that you see there. That's what you're saying.
Right.
Yes.
Yes.
Yeah.
So actually, I think if you build a distribution, I think it's reasonable to create your own binaries.
Yes.
So, yeah, and that apparently did not happen in these early streams of these few.
So the binaries were created by this individual.
Yes.
And they were one-on-one verbatim copied without validation of signatures or whatever.
Yes.
Kind
well, actually, there is a test on the signatures, and the test was subverted as well.
Ah, nice.
Because, of course, the actual checksums that you check the integrity against.
I see your point on the nation-state actor.
Yeah.
Indeed.
Yeah, it's pretty sophisticated, but not sophisticated enough to go undetected.
Yeah. So how did that happen? But how?
Andres Freund was investigating a software performance regression issue. He was testing the authentication performance, and he realized that it takes too long to perform the authentication through SSH. He was investigating a delay about 500 milliseconds, which is half of a second, and in CPU times this is a whole century, as you can relate. So his curiosity led him to reverse engineer the whole thing. And
because he figured out, hey, since this version is suddenly super slow.
There have been a number of coincidences, as he stated, that have happened and helped him to decide to insist with the investigation. And finally, his investigation was really successful. He informed the open source software, mailing list, the security mailing list about his finding, and then things, have been revealed. And suddenly Jia Tan was disappear.
No commit from him anymore. Not under that name or her. Yeah.
Based on what we know, as we said, with
of course, reverse engineering stuff and actually examining what happens is never entirely impossible. But in this case, Mr. Freund could actually inspect the running source code, so he could see a difference between expected behavior just by evaluating what the code would have done and what he observed to be happening, and something different happened from what should happen. Ergo, someone has messed with this. So, and that conclusion could be drawn at least quicker because he had access to the internal workings of the software he was trying to understand.
Mm-hmm. So, and was he able to reproduce what was injected? Can I mention that he then built the binary himself and reverse engineered that? Is that do we know about that?
Well, based on what we know is that he investigated all the files on on an affected system that had this huge delay with authentication, and he found out the scripts that were running the malicious part of the code that were injecting the backdoor. So there can be other things that Andres did during his investigations, but we are not aware of. And other methods as well. So we are not pretty sure what he really did, but definitely what he did paid off.
Yeah. So binary objects got distributed. They contain scripts, and as far as we can tell, they were very convoluted. Again, nation-state actor level type of obfuscation. So in the end, it's pretty hard to actually reproduce them. And in that detail.
Yeah,
but we can observe the actual transactions, of course, and we know we can actually understand the injection in the handshake in the authentication phase. So we can identify the results, not so much the exact steps.
We called this one. Huh? I mean, it's hard, even in open source, it's hard because, of course, we talked about this on Thread Talks before. I mean, there's so much code. It's impossible to audit it all. So there may be other things. Does it matter? Is it easier, you think, in open source to detect these things, or at least investigate? We get that. We fully understand what's going on. What if it were closed source, or maybe it is a library in a closed operating system where nobody sees the source code, because you can also try to infiltrate in a commercial company. Huh? So the nice thing about this one is it's wide in the open.
Well, if you allow me, I think the closed source thing is the worst of both worlds. But you can't actually inspect the running product. But the running project probably also contains any number of open source libraries, except that they will not be updated, and you can't do that yourself either. So basically, for example, SSH runs on Windows as well as of Windows 11, I believe. It used to be an additional package in Windows 10, but it's now basically part of any. So and Windows isn't open source, right? So basically, any networking software uses. At the level of the network layer, a transparent compression mechanism, like the XZ library, but sometimes it's the Z library or similar things like that. And well, there's this diagram that's often shared, in which you have this complex picture of the entire internet, in which large, monstrous clouds here and there, and they're built on top of other facilities, and the end there's just this small stick, which is curl.
Yeah,
and libcurl is really used everywhere.
Yeah,
closed source, open source. And the difference, of course, is in open source we at least have a fighting chance to diagnose and fix it, and in closed source we just don't. We also know, and this is a digression, I believe, but we know this, for example, from the file Snowden released, that there is this long-standing tradition in nation-state actors to actually distribute backdoors inside commercial closed software. Sometimes we find them, and sometimes that get fixed, and sometimes we didn't discover that the actual fix consists by removing one backdoor and inserting another. So that's closed software for you.
Yeah, and that is not all visible. Nobody can even, like you say, we don't even have a fighting chance. We are depending on the company that maybe also doesn't even have all incentives to be open about it if they find something. I mean, we've seen some examples of those as well, where cloud services were very vulnerable, and the notification was some vulnerability, and customers leaked some data.
Yep, we fixed bugs and improved performance.
Yeah, exactly. Yeah, and nobody knows.
Release notes.
But, yeah.
Number 1 to 7,000.
Yeah, I don't think we're going to change the world in opening all their source code. Huh? Maybe we have some hackers that get well. Sometimes you see that.
Yeah, but we have tremendous power, of course. And if I just go to one meta level above, there is this thing which is a human error, and this is hubris. We overestimate our capability in controlling the complex technology that we create and deploy. So one of the things we can try to fight is our instinctive impulse to just keep adding complexity to systems that are already too complex. And I think once we succeed in limiting the complexity we add to systems, we have a better chance of actually making them more robust.
Yeah, I think that this supply chain attack revealed a number of things that should have been held differently. Personally, I believe that it was a very good coincidence, the fact that what happened with the open source software, because if it was on a closed, group software, things would have been way worse, because indeed we have the fact that the backdoor has been identified by a person who wanted to contribute to the open source software community. He investigated, the performance regression issue of the 500 milliseconds, and he finally found out what was going on. Would have been the case this for the for the closed group software? I don't think so.
Do you think that in the open source community, people are aware enough about their software bill of materials signing, all that and stuff? Is enough being done there, or is it in its infancy?
I think that we can definitely do better. We can, improve our processes in general. And it was revealed that you can't rely on a one-man show to maintain.
We do rely on many one-man shows.
Yes, the truth is that as things are right now, we rely on many one-man shows. This is the truth. And we must change this. I mean, we must apply some four eyes principle. Here, so for software or for pieces of software that are publicly distributed, and so popular, we should be more cautious with regards to who is committing, if a single person should commit, and so on. So there are deals.
Even if you have things like this, right? Our company has this. Every change is always a four eyes principle. Every merge request needs to be reviewed, security reviews, and all that. But you still use those open source tools that all those commits you do not review.
Yeah, but also in open source land, of course, many organizations that do open source are mature. They have mature repositories, mature ways of validating the integrity. And the chain of responsibilities, of course, is very long. As Thomas points out, in the end, you need reliable source material. So the package maintainers themselves, they are a weak point, but much has been done to actually enforce or ensure the validity and integrity of updates across that chain. Some of this went wrong in this case also, I believe. And as I said before, I think if you have a distribution, you should not pull the binaries from the distributor. You should actually build those stuff yourself and sign them yourself, so that you take responsibility for the entire trace up to the source code that you're distributing yourself as well. So there is room for improvement, but we have an ecosystem that in the end is founded on fragile human beings that we do need to support as humanity.
This was not the most optimistic threat talk we've ever been on, I'm afraid. Yeah, but gentlemen, thank you very much for all those insights. There's work to be done. It's a very interesting story. I recommend you look at in the show notes and all the documentation we provide you with, because it's very interesting to learn how nation states can get into an open source project that is then going to be distributed on many, many systems. Luckily, we got away with this time, but if we wouldn't have, we would probably have quite a different talk with lots of damages and everything. So it's great that security work pays off from time to time. Gentlemen, thank you very much. If you enjoyed this show, please like us. It helps us spread the word more. If you subscribe to our channel, you will get the next episode in your inbox next Tuesday, because we have one every week. And thank you very much for tuning in. My name is Lieuwe Jan Koning, and from the floor here at Onto It, Thank you very much for watching. See you next time. Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.